capacity or whatever we can.
Yep,
and hopefully...
good to go.
I'll give it a go, but it didn't work before.
Okay, sounds good. Perfect. Well, I can push the live now tweet. Because we are live, officially. And I'm going to mute everybody just here at the beginning, and then you can feel free to unmute yourself whenever you're ready to go. All right. Thanks for joining us once again. I'm Sammy K. Powers, and this is the PHP Roundtable. This is a live podcast of developers discussing topics that PHP nerds care about. The ultimate goal of this podcast is to learn a little something from each other. And if you're listening live and you want to be a part of this little shindig, send a tweet to PHP Roundtable with a question or comment, and we'll try to get your comment or question answered right here live in this episode, if we can. Today, we've got a smorgasbord of security-related topics. So we might talk about some PHP Fig security-related PSRs, and we'll probably chat about hashing and encryption in general. And we could possibly talk about what Libsodium is and how we might use it in our PHP apps. And we might wrap things up with discussing some new encryption features of PHP 7.1, but we'll talk about it all under the umbrella of general security things, and we'll just see where this thing takes us. Now that we know what we're talking about, let's meet the panel. And as always, in no particular order, we're going to meet the security engineer at Paragon, Scott Arciszewski. And I actually messed up your intro because I started to write it down, and then I got distracted with something. What was the rest of your intro that I can't remember what it was going to be.
I'm just the security engineer, chief development officer at Paragon Initiative Enterprises. I do open source security research and cryptography stuff.
Yes, that was what I was going to say, but I didn't write down because I had to switch places. Sorry about that. But welcome back. We also have Chris Riley, who's a freelance software architect from York, UK. Welcome, Chris.
Thank you.
And finally, we have another Chris Cornutt, who was the developer shoutout from last episode, returning to the PHP Roundtable again. He's the application security engineer for Salesforce and the creator of the Securing PHP project. Welcome back, Chris.
Thanks. Good to be back.
Absolutely. And we also have potentially Sarah Goldman joining us later on, whose one-liner intro is, "I like to be fashionably late to podcasts." So if she does end up joining us, we'll have her just start chiming in as if we already introduced her and everything. So let's see how that works. So today, we're just kind of talking random security topics and just kind of seeing where this conversation goes. But I did want to at least kind of kick us off with looking at the PHP Fig, which has two PSRs out there, PSR 9 and PSR 10, that are specifically addressing some security issues or the topics of security. Does anybody have any thoughts on, first of all, what those PSRs are, the security advisories PSR, which is PSR 9, and then the security reporting process, which is PSR 10. How are those, what are those two PSRs, and what are they supposed to be giving to the community?
So I was in the group along with Lucas and I forget, there were one or two other people that were kind of involved there at the beginning. We decided that since there were so many different ways to report security issues, and there really wasn't a good standard way to do it in PHP applications, that coming up with a good standardized format and standardized reporting process was kind of the way to go on that. Unfortunately, it has fallen kind of by the wayside. We haven't really worked on it in a while, but the intent is still there. I think I still see it as something that's definitely needed in the community. I hope that those, keep moving forward, and, I keep trying to find the time to pick them back up and move forward with them. But, we're all busy people, unfortunately. It would be nice to have something. There's the, I forget what the repository that the Symphony folks put together. I forget what it's actually called, security advisories or something. They've got that one out there that it's, some of the stuff is kind of loosely based on the data, the metadata in the reporting structure. Like I said, it's kind of stalled at the moment, unfortunately.
I know Rove has their own cool little thing that will actually block you from installing vulnerable packages with Composer.
Cool.
Yeah, I think that's based on that repository contents.
Yeah, it's just a package that you require in your composer JSON, and it conflicts with every unsecure package version, so it stops you from actually having them installed.
That's really cool. Yeah, I think I saw the repo on that, and it was just basically like a giant composer.json with a bunch of version numbers that were showing like you can't. That would show how you couldn't install them if you tried to install them from Composer or something like that. It's kind of unique way of addressing that issue. So on the PSR 9 and 10, is the security disclosure PSR, which is number 9, is that about like if you have a security or if you have like an exploit in your software that you would basically, here's the process of like reporting it or like how to handle those situations? Is that what that's about?
So one of them is about the actual structure that you use in your repository to say, here's the list of vulnerabilities that I've had, you know, in an easily script parsable format. So you can go through and say, you know, this version number had this vulnerability, you know, this is how serious it was, you know, any mitigation things that you can do, you know, what version you need to upgrade to, all that. And then there was the other side, the 10, that was kind of more of reporting vulnerabilities to projects. You know, you should have a security @ email address if you have, you know, if you have a domain or whatever related to your project. You know, just simple stuff like that. Yeah, I don't think I know we worked more on PSR 9, and I don't think there was quite as much discussion around 10.
So PSR 10 would be more of like that human interaction of like how security related things are reported, and then PSR 9 would be like here's how we're going to report our security holes or whatever. Like this is how we're going to publish this and consume this.
Because they had the you know, the security advisories repository that had that publishing method, you know, and this was just kind of the idea was having it a little bit more automated. And making it simpler to report those issues, just because, you know, if it's not simple, people aren't going to do it, unfortunately.
Right. True that. Will be interesting to see where that goes eventually when things kind of get published and it becomes an official. It's just in draft mode right now, right?
Yeah, it is. And if anybody listening wants to help out, let me know. Ping me on Twitter. I'm happy to bring you in the loop on it and get things fired up again.
For sure. That'd be awesome.
Scott, Chris, that includes you guys too. Not to put you on the spot.
Yeah, as somebody who reports a lot of vulnerabilities to random projects, having a standard way of going, oh, this is how they want it reported, and these are, you know, this is where the information is going to be published after it's been fixed, would be very helpful and saving time. Usually when I go to a project, I look for the README, I look at the composer.json, I try to find the developer's email address to tell them discreetly, hey, you've got a remote code execution vulnerability. Here's where the problem lies. I can make a proof of concept if you need it. Here's how to fix it. Sometimes I can't even find that information, especially if people don't have their email address configured on their Git history. So that would definitely help a lot in getting security issues fixed quickly and effectively.
Yeah, for sure. Yeah, you do a lot of that. You do a lot of, it seems like open source auditing, don't you?
Yeah, usually because the library is used in a project that's interesting to a client or to something that is interesting to the community. Depends on whether or not I'm busy or if I'm just, you know, hey, Joomla is the 3rd most popular CMS. Let's see how they're implementing this. Unfortunately, I have like a 50-50 hit rate, so I'm trying to get that number a lot lower, so where if I look at a code base, I don't actually find anything because everybody knows about how to fix them. That's kind of what we try to do with our blog posts. It seems like it's a lot lower than it was 2 years ago, though. So we're definitely making progress there.
That's awesome. Yeah, it does seem to be like a more of a topic that everybody's starting to talk about a little bit more. I feel like just because of people like you guys here, kind of with the InfoSec evangelism, pretty much the way I see it. Because I seriously like I've learned so much, especially from you, Chris Cornutt, and Scott, from the interactions that we've had in the past. Like, just I've learned so much. I'm like, oh man, what would Chris do, or what would Scott do in this situation? Chris Riley, you were about to say something?
Yeah, I was going to say, I think the format for actually having the vulnerabilities listed is possibly the more important of the two PSRs, because obviously once you've got the vulnerability there, the faster you get people to upgrade, the less likely they are to get sort of attacked and actually have problems with their application.
Right. Yeah, for sure.
Yeah, one of the problems we've been trying to tackle both at a community level and in our own projects is secure automatic updates. We just put out a blog post earlier today, basically all the elements you would need in a secure system that automatically updates your software, and why auto updating is very important for the security of the internet. So having something that would actually like get the information out to people that, hey, this needs to be upgraded, and block vulnerable versions like the Rove library does. I think it's under the Friends of PHP namespace. Those are both very important to stopping attacks. If you look at the 2015 Verizon data breach incidents report, they found that when a vulnerability was used, 99.9% of the time, it was at least a year old from its public disclosure before it was exploited in the wild.
Wow.
Yeah. So that's the part of the vulnerability lifetime that developers have the least amount of control over.
Well, yeah, go ahead.
Yeah, I was going to say, of course, the advantage of the Rove composer package is that it'll just block you the next time you sort of do a deploy of your software. Because once you try and pull in those vulnerable packages, it'll block it immediately and allow you to take action almost straight away. So if you're a company that's doing quite a lot of deploys and builds in a week, then you'll pick up those fixes pretty quickly.
Definitely.
Cool. Well, kind of shifting gears a little bit, what is the, when we talk about security, it's sort of like there's so many things, different topics we could talk about. But a lot of people, when they think security, they automatically sort of think about encryption. Like I had encryption in my head, so every word that I was saying began with the phoneme. And so what, when it comes to encryption and things, what should we be thinking about? Like, especially if you're kind of new to security or encryption, what are some of the ways that we need to think about, like when I have my data at rest versus data being like in transfer versus like I have a file, like a big like binary file I want to encrypt? Like how do I like wrap my head around how I should handle encryption in different contexts?
Well, the first thing is make sure that you're actually like you need to encrypt something versus like hashing. I know a lot of companies, when they say they store passwords encrypted, they're talking about, like what Adobe did when they used triple DES to encrypt all their passwords. Most people actually, when they say they encrypt their passwords, they mean they use a password hashing function. It's just encryption has kind of become the buzzword for that. Being clear on what your goals and requirements are is probably the most important thing, because even if you implement, a secure encryption, but you needed to store a password, if an attacker gets on the server and steals the key, now they have all the plaintext passwords. Most problems can be caught from a design phase. That's the most important thing. And the other thing is to understand that encryption itself is very limited. It provides confidentiality, but unless you're using a specific mode, like what's called in the AEAD mode, which we'll probably get into a little bit later with the OpenSSL changes, it doesn't provide integrity out of the box. You either have to build that yourself or use an AEAD mode. AEAD is an acronym that stands for Authenticated Encryption with Associated Data. And if anybody's interested, there's actually an ongoing competition amongst cryptographers to design the next generation AEAD implementations. I've been following the entries. They're in the third round right now. It's called Caesar. I think they'll be announcing the finalists later this year or early next year.
That's awesome.
Yeah.
So when authenticated encryption with associated data, AEAD. There's so many acronyms in computer stuff anyway, but like it seems like security has its fair share of its own acronyms that are like you got to remember all of them. But with this particular one, authentication. I feel like when we think of authentication from just sort of like a web developer kind of like fiddling around with authentication, we think, oh, like logging a user in. But really what we're talking about with when it comes with encryption is that we want to validate that the data hasn't been tampered with. Is that right? Like when you encrypt something, you need to make sure that no one's touched it?
Yeah, a lot of people have taken to calling message authentication integrity. It's an integrity checksum. But that gets a little bit confusing because most of the algorithms for that are what's called a message authentication code. And so then you get an overload of terms and it gets very confusing for people just trying to learn it. Message authentication and user authentication are totally separate, even though they have a word in common. Message authentication, you might apply a hash function that's built a special way where you actually apply it twice, and the first time you pass in a secret key, and then both parties know the same secret key because you already negotiated that with like a symmetric key, or sorry, with an asymmetric key exchange, or it was already just established in the code somewhere. And key exchange is actually one of the more brittle parts of cryptography. That's fortunately most developers don't ever actually get their hands dirty with that part of it. They just install a SSL certificate and make that somebody else's problem.
It's much better when it's somebody else's problem.
Yeah. Yeah, it's too many ways it can go wrong. Trying to implement secure RSA encryption, especially in PHP. Like there was a question on Reddit that was posted yesterday in the PHP subreddit. I gave them an answer and then it like immediately got deleted. Because I linked to the late last year, I reported an issue to Zen Framework about a padding Oracle attack in their RSA implementation. And the fix was literally passing a constant to the third argument of the function for OpenSSL private decrypt. But something as simple as an oversight like that could make their application vulnerable to what's called a chosen ciphertext attack, which is a chosen ciphertext attack is literally you change the encrypted data, you send it to the application, and either based on an error message or some kind of information like how long it takes to return an error, even if you don't know what the error is, you can actually slowly decrypt the entire message. Cipher blockchaining mode for most block ciphers, if you're using PKCS7 padding or some other reliable way of getting an error oracle out of it, you can actually decrypt a message by changing a few bits when you get a value. If you get a padding error, or if it just goes through, you know that you've got you can actually, it's actually pretty difficult math for somebody just starting out, but you can take the entire message, break it into blocks, and decrypt them one byte at a time based on the error status. Ciphertext integrity or message authentication actually solves that problem as long as you do it correctly. And whenever a cryptographer says do it correctly, they're implying like 8 or 9 different things you have to get right. Like you have to use a random initialization vector if you're using CVC mode. If you're using RSA, you have to use a modern padding scheme like OAEP, which stands for optimal asymmetric encryption padding. Like, you're right, there are acronyms everywhere. And just keeping track of the acronyms can be painful. I was writing documentation for an RSA protocol enhancement, and as an oversight, I accidentally recommended OAEP for the signing when it's the secure padding scheme is called PSS. So even I make mistakes on that one. It's very easy to, run into a bunch of issues on that. So when it comes to doing encryption and authentication, the trick is to encrypt and then authenticate. So what that means is that you would take your message, like let's say it's just, I don't know, hello world. You pass it to your cipher, like AES, in a mode that isn't ECB mode, something that actually, is indistinguishable from line noise. And then you take your ciphertext and you pass that to your authentication function, which is probably HMAC, with a separate key. And you'll take your MAC that it gives you, which will be like a hash output, so it'll be like 32 bytes or 64 hexes if you don't pass true. And you stick that at the end. And generally, if you're using like CVC mode or CT or counter mode, and you have an initialization vector that's part of the process, you'll also include that in the HMAC input. So you'll generate like 16 random bytes. You'll pass the random bytes and your key and your message to AES. You'll get your ciphertext. You take your IV or your nonce. That's what they call the 16 random bytes. And your ciphertext message, you pass that to your HMAC as the message with another key. You take your ciphertext and you send that all as one shebang. And then when the person goes to decrypt it, first you'll recalculate the HMAC value of your entire message, and then you'll have to compare the two and make sure that it always takes the same amount of time to compare the two strings. Otherwise, people will find a way to slowly forge messages, and you get back into your padding oracle state. And if that, if the message is complete, or the hash at the end comes out to be the same, then you decrypt it using the nonce or the IV that gets passed along with the message. That sounds kind of trivial if you know what the terms are. I mean, this probably sounds like I'm speaking Greek to everybody right now, but you'd be surprised. I think there's only like a handful of libraries I've looked at that I had never touched, or a couple other people in the community that know cryptography had never touched, that were actually implemented safely. And I think Laravel was the only one I hadn't touched, but I think somebody else had already beaten me to finding the issues with it that didn't have any like obvious vulnerabilities, which is weird because it like used JSON encoding on the message after it was encrypted or something like that. Yeah.
That's pretty intense.
Yeah, and that's just for like encrypting a message where both people have the same key. When it comes to like if you have you're doing public key cryptography where you generate a secret key and you give everybody else your public key and you want them to encrypt messages to you, you get into situations like the RSA padding oracle vulnerability. That's if you use the default padding PHP gives you, which is called PKCS1 version 1.5 padding. Modern RSA padding schemes actually use hash functions to generate like a bit mask. Makes it a little bit less. It doesn't leak as much information if you manage to actually like flip a bit here or there. Another mistake you could do, like solsect it and set your parameters to where E and D both equal 1, so your ciphertext and your plaintext equal each other. If you're trying to encrypt a large message with RSA, another mistake people make is they'll take the log, it could be like megabytes of text, and they'll just break it into small chunks and encrypt each one independently. That you can just reorder, replay, or delete blocks however you want. You get a lot of control over that. Depending on what the protocol does underneath that, you can probably just forge messages arbitrarily, even if they're using the correct padding mode. So it gets really complicated quickly. And then you have to consider, like, there's this thing called side channels. Like I mentioned, the whole, if it takes the same amount of time, you're good. If it doesn't, when you're comparing HMAC values earlier, if like the first word, because PHP does a word base instead of byte by byte, is the same, it'll take slightly longer than if they're different. So you can actually use this information to slowly figure out the valid MAC for a message that you're providing under that key. There are other side channels that most people wouldn't think about. If you're using AES, but you're on your hardware doesn't support the AES NI instruction set, you're using a software implementation of AES, which does something where, as part of the way the algorithm works, it takes secret key data and uses that in array index lookups in the C code. And as a result, you can actually leak information about the secret key through what's called cache timing attacks, which some of your code will be stored in the like the L1 cache. Other times it'll be either in RAM or in like the L3 cache. If you clear the caches and then like with another process on the same machine, and then you are observing how long it takes for arbitrary messages to get into the in and out of the system, you can actually leak the key that way. I think a proof of concept back in 2000, I want to say 2014, it took like 65 milliseconds to do that against OpenSSL. So it quickly balloons into a whole world of complexity where simple things like equals equals becomes a matter of, hey, this could be a huge security flip bullet, and you can't really expect most developers to understand all these acronyms, how they work together, and the security implications of them all, because everybody has a job to get done. So generally, the advice people say is don't roll your own crypto unless you know what you're doing, because I've mentioned 2 use cases. I haven't mentioned signatures. I haven't mentioned password hashing, and that's probably already more complexity than most people really want to care to hear.
Well, it's definitely it can definitely be overwhelming, especially if you're first starting to get into it. But something that there's a lot that you mentioned, but one thing that kind of stuck out to me is you mentioned something about if you're using the AES algorithm for encryption, if you don't have hardware support for that, that's where your keys can get stuck in the cache. Whereas if you already had hardware support for it natively, it treats the keys kind of in a special way.
Yeah, it doesn't actually store them in cache. It stores them in processor registers. Most processors, especially Intel ones, since like I think 2005, have AES NI support, which I think NI stands for New Instructions. Correct me if I'm wrong. I don't remember the exact acronym on that one. Acronyms are even a bit much for me to keep up with sometimes. But generally, you can almost always assume that you have that support, but there will always be those weird systems where it doesn't, and those are the ones that are going to be vulnerable. And there's not much you can do about that unless you want it to be really, really slow. There's this technique you can do to actually make it constant time and not leak information through cache timing, but it's called bit slicing, and I think it makes it like 20 times slower than software. And that was benchmarked on AES and GCM, which is the Galois counter mode, which is one of the AEAD modes that OpenSSL 7.1 allows us to use. And that's probably a good opportunity to segue into that topic if everyone's interested. Okay. So as of 7.0 in OpenSSL, the underlying library supports two modes called GCM and CCM. If you connect to your Google Chrome on Windows, you probably, if you look at your connection information, it'll likely say it's using AES 128 GCM and a bunch of other stuff. That's one of those authenticated encryption with associated data modes that cryptographers tell everyone to use nowadays because it's just safer than trying to roll your own protocol. It uses a combination of counter mode, which is basically you take your initialization vector, you increase the bytes. I think it'll be significant at first. And you get basically a long stream of, like for every 16 bytes, you'll increase the counter by 1 and get another hash or AES output. You'll get this long stream of seemingly random bytes. And then you'll just do an exclusive OR with your plain text message, and you'll get your ciphertext. And that's theoretically as secure as like a one-time pad. But you don't have to have a key as long as your message. You just build it off of your AES key. And then it uses a technique called G-hash, which is a, I think Thomas Tadchik refers to that as a thermonuclear cyclical redundancy check. It's basically a way to, it's a similar to like a hash function, but it's based off Galois fields, which is, abstract algebra thing. And it does all this and gives you like a checksum that's like 32 bytes or whatever. 16 bytes. That's your authentication tag. Up until 7.0, PHP didn't have a way of actually getting the authentication tag when you use GCM mode or CCM mode. So if you wanted to use authenticated encryption just from OpenSSL without having to do any of this higher level stuff, like with hash functions, you were kind of SOL. You couldn't do it. Like you could encrypt, but then you couldn't decrypt because there was no authentication tag. So one of the RFCs that affects 7.1 actually exposes the new parameters on OpenSSL encrypt and OpenSSL decrypt that you pass in a reference to a string, and it populates with the tag and you can say, this is the tag length. I want the tag to only be 8 bytes long, and I'll give you 8 bytes of the tag. And then when you go to decrypt it, you get the same information. And if your message is authenticated, boom, you got your plain text. Otherwise, I think it returns false. I need to look into that. But that's a much safer way of doing things than starting with CBC mode and trying to roll your own HMAC implementation. Well, not implementation, but protocol.
Yeah, Chris, you had something that you want to chime in there? Chris Riley?
Yeah, I was just going to say it does return false if the tag fails.
Sorry. Oh, it does return false?
Yeah.
Okay.
Well, according to the RFC, that is anyway.
Yeah. Oh man, I should have bike shredded that instead. I should have thrown an exception.
Yeah, that's actually something that we had to discuss when implementing the random bytes and random int in the PHP 7 was whether they should. At one point, it was probably, I think it was like release candidate 3. It was returning false if it couldn't find a reliable C-spring, and luckily the PHP community allowed us to go in there and fix that behavior and actually have it throw an exception instead of failing close instead of failing open, especially with these cryptographic contexts.
Yeah, that was the reference to the joke I was making. But yeah, generally, that's when you do anything with cryptography, you want it to fail closed in such a way that you can handle it gracefully. And PHP's exceptions are pretty much ideal for that use case, because if it fails closed all the time and just crashes your application, it's going to scare people away. They're going to go, why would I use this feature if it just crashes my application randomly? Do not want. But if it just fails open, people will be proceeding insecurely, like, oh, my password is A. Oh, that's just fine. No security risk there at all. But it's a good compromise between two extremes, between people letting failures just exist in the system and letting people be insecure and not know it, and then scaring people away from the secure solution towards insecure ones that just work.
So we kind of, in like a bigger context of just where I implement certain encryption or where I implement hashing, are there sort of like a list of things that you can think of off the top of your head? You're like, okay, you should definitely probably in most every case encrypt or hash this, or make sure you have encryption on the wire here and things like that?
I think the most obvious one there, top of the list, would be passwords. You should always hash them. And not only that, but use a slow hash function, such like bcrypt or scrypt, or the newer one that's in Libsodium.
Argon 2.
Argon 2, that's it, thank you.
Yep.
So obviously, if you've got a fast hash, something like SH256, SHA-512, something like that, it's used in Bitcoin mining, and you've got dedicated bits of kit that you can buy that will do trillions of hashes per second, which means you can brute force through the most common trillion passwords in a second or so, and basically decrypt the whole database pretty quickly and efficiently.
Yeah,
so it's very important to use sort of like bcrypt or something like that.
Yeah, so with passwords, like Chris said, if you have like a really common password, people are going to try to guess that sooner than a less common password, just because they don't want to waste CPU cycles when they're trying to guess your password. So what if you have like a fast password hash like MD5 or SHA-256 to store your passwords? Somebody will just take the hash, and if you have like a homegrown salt system, you just prefix it. They'll just go through like all the really obvious combinations and then like permutations of those, like Hashcat does, and it'll take them a very little amount of time to go from I have a password hash to I know the corresponding password that creates that hash. Hashes are irreversible, but they are deterministic. So if you know the hash output, you can replay different inputs to try to find it. Password hashes are algorithms that build upon hash functions usually, that they don't just take a lot of time. The newer ones also, if you want it to go faster, you have to use a lot more memory. Or if you don't have that much memory, you have to take even more time. Scrypt and Argon 2 have that property. It's called a time-memory trade-off. But the end goal is to make it to where this whole brute force attack, where you can try like trillions of passwords a second, becomes less in the favor of attackers and more in the favor of defenders. You don't want it to be too slow to where it takes 30 seconds to log in, because then you have a brute force attack and everybody hates the experience. But if it takes like 100 milliseconds to do a password hash, then each one of those guesses that might only take like a few nanoseconds on their rig now suddenly takes, 100 milliseconds, no matter what kind of hardware they're using. Maybe they can trade it down to 50 or 25 milliseconds, but the order of magnitude is still about the same. You don't really get a lot by trying to attack it. So you can guess from, 1 million hashes a second to only like 100,000. That's a 10 times gain. And if you can get it down to less than 1,000 a second, suddenly the scale tips towards defense rather than offense. And even if you have a password hash, it takes a lot of resources to figure out the password that went into that. And people have this idea that salts are like this magical thing with passwords. I think like people always say, oh, we use salted hashing, we're fine. Salts aren't like cryptographic secrets. They're not like your AES keys. They should be generated just the same way using devu random or a random bytes function for PHP 7. Or if you're using the password hashing API, just let it do its own thing. But all they're meant to do is actually distinguish to where if two users have the same password, but they have different salts, they'll have a different hash. So it makes it harder to do like an economic attack where you crack it once and then everybody else has the same password. And plain MD5 doesn't have this property.
Yeah, so I went to Enrico Zimmel talk at ZenCon, and he was talking encryption, authentication, and data security integrity in PHP 7. And when he was talking about a couple different aspects of security or mainly encryption and hashing, he talked about iterations. So like how many times I guess something is hashed over and over, and he mentioned that like right now where the way that computer processing is, where the kind of the sweet spot for iterations is around 80,000 iterations, and the I was looking at there's a function in PHP called #PBKDF2 that you can apparently use. You can actually tell it like how many iterations to hash something. And in the documentation, the default iterations is 1,000. And I asked him about that, and he said it probably should be set to at least 20,000. But I want to go in there and update the docs to maybe also update the C-Spring, which is right now it's telling you to use mcrypt create IV, but mcrypt is deprecated in 7.1. So we probably need to change that to use random bytes and then use a polyfill if you don't have it, kind of thing. But at least with the iterations, what are the trade-offs of, like, because you're kind of already alluding to it when you mentioned kind of like how long it takes to log in. Like if it takes 10 seconds to log in, that's probably no good. But like, what are the realistic trade-offs on what are the defaults that you tell users, like you should at least iterate 20,000 times, but ideally you need 80,000. But in this context, you probably won't have the CPU, so it needs to be more like 30,000. Like, how do you explain that in documentation?
So the go-to advice when people ask about iterations, and this is a PBKDF2 specific thing. With bcrypt, you have something called a cost factor. The default is 10. I think most people use 11 or 12 nowadays because that's an acceptable, value for them. Argon 2 has its own levers you can configure, but if you're using, Libsodium, you can just say, I want it to be an interactive password or I want it to be a sensitive password. And the sensitive one takes like 3 seconds on my computer to calculate. The rule of thumb is to benchmark it, figure out how many people you're going to expect to have logging in. Like, you're probably not going to have, unless you're like Facebook or some large organization, people logging in all day, every day. It's going to come in bursts. And usually the bursts are going to be at like opening business hours, like 9 in the morning. If you have like 1,000 employees that are trying to log in the space of a minute, you know that you have 3,600 seconds in a minute. At most, it should take 3.6, 1 over 3.6 seconds for each person to log in order to safely get everybody in the system. You figure out how much time you can take, and then you benchmark how many iterations it takes to get to that point. If you are over 80,000, you're probably fine. I know Taylor Hornby's diffuse encryption library, the PHP encryption one that I pretty much recommend anybody who can't use Libsodium use. If you use a password-based key, it actually uses 100,000 iterations just for the sake of being future-proof. So I think like 10 years ago, everybody was using 1,000 iterations, and now the recommendation is 80,000, so 100,000 is a pretty good safe bet for most people. If you find out that it takes like 0.01 seconds for somebody to do 10,000 iterations, and it takes 0.1 for somebody to do 100,000 iterations, 80,000 is probably fine. I think the golden rule of thumb most people go with is 80 milliseconds or 125 attempts per second is what most people try to aim for. It depends on how many users you have and what kind of traffic you're expecting. Another thing to keep in mind is if you have a lot of people, or if you have a really high cost, you're probably going to want to stop people from trying to log in a lot. and implement some kind of rate limiting, so you're not just creating a DDoS or a DOS amplification vector where people can just send a bunch of garbage password requests or login requests at once and hog up your CPU with password hashing. Because that is definitely something to keep in mind. If everything takes like 3 seconds and requires 100% of your CPU and half your RAM, as soon as you have 3 people logging in at the same time, you've got issues. So there's always a trade-off.
Oh, we have a DDoS attack. Like, no, just 3 people try to log in at once.
Yeah, it's very careful. It's a careful balancing act. You don't want to create bottlenecks for you, but you do want to create bottlenecks for the attacker. It might seem like it's still pretty fast if it only takes a few milliseconds, but when the alternative is taking a few microseconds or nanoseconds, like a MD5 or a Blake 2 hash, it is a significant gain, and your users won't notice it, but the attacker definitely will.
Right. I like that you mentioned that instead of thinking about the number of iterations, like if you just aim for like the amount of time it would actually take to hash on a particular system, that's kind of the sweet spot to aim for, because that's always going to, no matter how fast the CPUs you'll get, that's going to stay constant, but the number of iterations will change. If there was some sort of, I'm just curious how this would work though. If you have sort of, maybe, I don't even know if there's a package out there that'll do it for you. Be like, hey, here's my, like you run a command and it just tells you, oh, based on the system that I can see, you should do this many iterations for your password hashing. But there are, if there are issues when you have like a maybe you're running on like a small instance initially, and you optimize your hashing for that instance, but then all of a sudden you upgrade to like this insanely fast instance, does that sort of almost open you up to being brute forced, because now you're hashing your new architecture is hashing passwords in like split like just nanoseconds?
So one of the good things about the PHP hash functions, like password hash, etc., is that it actually has a password needs rehash function, which you can use to, if you re-benchmark your new hardware and determine that you want a higher cost function because you've got more power and computer technology's moved on, you could actually check the passwords as your users log in and see if it needs rehashing with stronger parameters according to your new benchmarks, and just sort of gradually improve the security of the passwords as people log in.
Cool.
Yeah, and the other side of that, if let's say you're using a bcrypt cost of 8 because you have a really cheap VPS from like low-end box for like $3 a year, and you're building like a startup app, and suddenly you take off and you need like several dedicated servers with like load balancers in front of everything, and it's like this crazy architecture growth, and suddenly you went from having 1 core to having like 16. Your gigahertz, your clock speed on your CPU is doubled. You have like 10 times as much RAM. If you upgrade your cost parameter to like 12, your previous passwords are only as weak as they ever were, because your attacker is going to use the hardware that they have on hand regardless of what the hardware you have. So if you had a really lightweight server and the attacker had like a cluster of like 1080p or the NVIDIA 1080, I think they're 1080p is what they're called, the new video cards for gaming, and they just hooked in OCL Hashcat, and like you have 12 cores and you have them just, doing their thing, wasting a lot of electricity, but, going through, millions of hashes a second, you were already vulnerable by the limitations of the system you're operating in, at least more so than if you were on your beefy server. Hardware, the attacker will always have their own hardware for attempting brute forces. The hardware you're on, if you upgrade to a beefier system, all that does is make it less vulnerable to denial of service attacks and give you the affordability to upgrade your hashes and upgrade your security on that against those specific threats.
How do you prevent somebody from taking advantage of the fact that the authentication, like basically creating these password hashes, takes time on purpose and takes resources on purpose? And how do you prevent somebody from just sending like tons of text to post on to your basically your login endpoints to actually generate a DDoS attack to shut your server down just to fill up all that processing power?
So The general rule of thumb is to do something called rate limiting. I can tell you how Airship does it, but I don't know if that's a little bit too specific and paranoid for most people. So what we do is we actually take, if you're on an IPv4 or IPv6, you can configure the subnet mask bit. So like a /32, a /24, or if you're on IPv6, you get like a /48 or a /64, which means that the least significant bits of an IP address are all treated as the same identity. I know a lot of IP address like logic people will just treat each one uniquely, which makes sense for an IPv4 address if the attacker only has one machine. If you've got an IPv6 address, the attacker has like, millions or billions even of IP addresses they can send requests from, so they can just walk around your restriction. So if you send a request for the same user account or the IP address, it counts as a hit against the same, it's like an OR rule. If it's the same IP subnet mask rule, or if it's the username, it counts them together, and if it takes a certain amount of time, it actually progressively slows down each request and says, either server side or client side, hey, you're doing that too fast. Wait 8 seconds and try again. You try, you fail again. It says, hey, try 16, wait 16 seconds, then try again. You try switching the username, but you're in the same IP address range, it says the same thing. So it's really hard to bypass it. Rate limiting in general basically means you control how many times a person can send a request to a specific resource. So that way they can't create like denial of service type situations.
Chris, you're going to say something?
Yeah, I was going to say one sort of obvious drawback to sort of locking a username if too many failed password attempts is that an attacker could potentially lock out the admin accounts. So one sort of defense I implemented against that for an application I was working on a few years ago now was if you got sort of locked out by IP or on a username, it would allow the admins still to log in if they were from an IP they'd previously logged in from.
Yeah.
If that sort of makes any sense.
No, that makes perfect sense. Generally, if an attacker is coming in for a specific username, they're going to come from a different IP address than the one you've always used, unless they have malware on the computer, in which case they can probably just steal your password and not go through the trouble.
Yeah, and for the IP restriction stuff, you need to be sure that that's per user, because if you're just counting how many failures from a certain IP, and you have everybody behind a load balancer, everybody coming to hit the system from the same IP at 9 a.m. on Monday morning, the first 30 people are going to get in, but then you may hit the throttle limit and get phone calls to the help desk because everybody else is locked out.
Yeah, that's definitely something to keep in mind. If you're behind the load balancer and your PHP application sees everybody as the same IP address, you don't want to do an IP-based lock at all because everyone's going to have the same IP address. There was something else I was going to mention, but it just slipped my mind.
While you think about it, Chris Cornutt, I haven't heard a lot from you recently, so I wanted to maybe ask you. I know it's not too specific of a question, but in terms of like in when you get a legacy app and you have to kind of maybe refactor the authentication and ACL layer, you go in there and you find that they're using, of course, MD5 hashing for their passwords, and maybe they're using Assault since it's super secure, right? But so you want to like upgrade the password hashing algorithm. How would you approach, maybe from the technical side of like how you would upgrade that system to something a little bit more secure on the hashing side, but also more of how would you maybe approach the sort of the human aspect of like, okay, everybody, you got to reset your password. It's too bad. Like, and then like, what's your sort of philosophies on that?
So I guess first thing, don't send out a massive email saying everybody has to go log in and reset their passwords. That's basically, on par with saying we had a security breach. Usually what I recommend is either the next time they log in, you validate their password against whatever the current hash is. And then, like Chris mentioned, kind of slow roll, update their passwords, and say, okay, you logged in, this was valid against this MD5 version. We have your password because we have it in memory. You just gave it to us and we validated that it's correct. And then go ahead and upgrade it to the next one to the bcrypt level and then write that back out to the database. Usually you can tell, if your script can look at the hash, it can tell what kind of hash it is. Right. Or what kind of hash it is. If it's not an MD5, it's going to be bcrypt. So you can kind of behind the scenes upgrade it that way. Alternatively, if you had some kind of a compromise and you want people to change their passwords because of that, forcing once they log in, say, okay, we validated the password that we have on file, but now we're going to force you to update your password, enter a new password essentially to update our security measures or something like that. I don't know how, different services phrase it differently, but then that forces them to put in that password again, hopefully a different password, but and obviously you want to check for that kind of thing, but yeah, you can, force that so that they can't continue to the rest of the application without updating that.
Just jump in and say that there's one other sort of thing you can do, especially if you've come across an application that is using something really bad like MD5, is you can actually go through and bcrypt all the MD5 hashes. And then when your users log in, you're obviously going to have to MD5 their password to test against the bcrypt hash, and then sort of rehash it with bcrypt only afterwards. But that sort of allows you to immediately get that jump in security without having to wait for everyone to log in.
Yep, just stored at rest in the better version, essentially.
Yeah, just throw in like a Boolean column that says like legacy password set to true for everybody, and then when you update it, set it to false. That was actually something that a Reddit user named Neothermic, is also on Twitter and hangs out on IRC a lot, suggested a while back ago, and I think it's a brilliant idea. I definitely do that in my own projects and encourage other people to do that too. But like the second thing Chris mentioned, if you had a breach, definitely force people to change their passwords on the next time they log in.
And you mentioned you don't want them to use the same password. Do you have basically a hash or like a table of old password hashes for each user that you would use, or do you just have a column that just remembers your last one, or what's sort of the best practice for that?
So usually in that particular case, I was just meaning, like once they log in, you have the password that they're using, so you can just rehash with that. Or, you still have that password, so when they put in a new one, you can compare against it. That's kind of the more immediate action right there. I have seen services that say, you can't use one of your last 5 passwords, something like that. Yeah, you do have to store old versions of it. But obviously you need to store those just as securely as, as you would the normal password, if not more so, honestly, because they're just lying around and they have the potential, somebody gets in, does SQL injection, some kind of attack on your database, and exports that stuff. Then they have all those passwords and they can say, oh, well, their password is probably similar to this now because, people put exclamation points and they put ones and, 1, 2, 3 at the end of passwords. And, they're really not that much different, unfortunately. But yeah, I'm not a huge fan of passwords. So
True. I've been updating my passwords. I have a password manager for my passwords, but like for the ones that I have to memorize, like I'm definitely switching my philosophy to not calling them passwords, but passphrases, so that I can really I just type this really long sentence as my password.
Yep. Yeah, that's definitely a recommended practice. It's it's too easy, and people have been kind of pushed towards the mindset that password is one single thing. But you look even at the XKCD correct horse battery staple example. Having a phrase that is unique. And even I've even seen some suggestions that say to incorporate something about the service into the password as well, or passphrase, sorry. So that they're different between services, which is another huge issue with passwords. Password reuse. Everybody's fallen into that habit where you use one password for 10 different services. And then Yahoo comes out and says, "Oh, all of our stuff was breached. You probably should change your password in other places too." You're never going to remember all those places,
right?
So I suppose this would be a good time to sort of bring up password managers then, and sort of suggest that what a good way of helping to protect your users is to make it as easy as possible for people to actually use password managers on your site. So don't do things like disable copy and paste on your password fields. Name them sensibly, like password. so that it can pick up the fields, and actually maybe just even recommend to your users to actually use a password manager for their passwords, because that's going to improve their security massively.
Yes, and the randomly generate function, preferably. Not necessarily the, oh, I'm going to put my own passphrase in there. Come up with a random 256 character password and just remember it. It'll be good to go.
Yeah, I can't even do that. And I remember some pretty long, crazy passwords before. This is actually a running joke with my family is like, they look at a little long string of text and they go, hey, that looks like one of Scott's passwords.
Well, we're kind of getting a little close to time to wrapping it up, but before we do, I really wanted to at least mention Libsodium, which is kind of the new-hotness encryption library everybody's been talking about. Is that the correct way to say? I know we've talked about whether it was Libsodium or Libsodium. I'm pretty sure it's Libsodium.
I'll have to ask Frank how he prefers to pronounce it since he's the author. I've talked to him a lot, but I've never actually thought to ask. So Libsodium is a modern cryptography library that only does like the most secure way of doing things possible. Like for encryption, it uses a mode called xsalsa20, which is a stream cipher that accepts a 192-bit nonce, which, if you can't really appreciate what that means, when you use AES encounter or CBC mode, your initialization vector is always 128 bits. So if you generate it randomly, you have like a 1 in 2 to the 64 chance of getting a collision as you encrypt more and more messages. At 2 to the 60, or sorry, you have a 1 in 2 to the 128. At 2 to the 64 power messages, you have a 50% chance of 2 of them colliding, which, depending on or what the messages are, could be catastrophic for your security. With Libsodium or Libsodium's encryption, it's, your probability at 50% is at 2 to the 96 messages, which I don't think anybody's ever going to meet. If you do, then you must have one impressive CPU. Because the difference between 63 and 64 is twice the difference between 63 and 62, because it's an exponential curve. So there's a lot of things that Libsodium does that are just secure. It only in the APIs that you're going to use, like CryptoBox and CryptoSecretBox, it only does authenticated encryption. It compares the message authentication code before it does the encryption or decryption. There's just a lot of subtleties that it gets right, so you don't have to worry about it. So instead of saying, oh, I need to generate a random number, and then I need to encrypt it, and then I need to take the random number and the message and make sure they're both covered by authentication tag, and then when I get the message, I need to take the authentication tag off and compare it cost of time. All you say is CryptoBox or CryptoSecretBox if you're not using public key encryption, and then CryptoBox open. And it's literally that simple. The only thing is you have to make sure you exchange the nonce back and forth, which is, that's still a problem that I think a lot of people would get tripped up over. So last year I started working on a library called Halite that abstracts a lot of this stuff away. And like, for example, instead of keys, which are just, in most cryptography libraries, strings of random data, and expecting people to get it right the first time, and not just accidentally put a password there, which is really weak and easy to, compared to an encryption key is usually like a predictable sequence of ASCII characters. It actually expects an object of a specific type, which in order to generate it, you can either derive it from a password, generate it randomly, or even save it to a file on disk and then load it on your next page load. So these are all things of, Libsodium. It gives you like the best in class cryptographic algorithms. All of them are side channel safe. xsalsa20, poly 1305, curfew 5519. None of them have cache timing attack vulnerabilities. None of them have any of these weird other attacks. Its use of curfew 5519 prevents a class of attacks called invalid curve attacks, which in classic elliptic curve cryptography, you'd send like an X and a Y coordinate. And if somebody sends an X and a Y coordinate on the smaller curve, they can actually leak information about the secret key that the other recipient uses over like 1,000 of these such exchanges. And then they know your secret key, so they can decrypt any message you ever receive. So it can get catastrophic pretty quickly. I don't think the standard ECDSA P256 is vulnerable to that specific attack, but I know other variants of other curve equations are. Curve 5519 it's based off a different algorithm. It's called a Montgomery ladder. Very easy to implement in constant time, so you don't have the side channel problems. There's just a lot of details that probably don't mean anything to anyone outside of cryptography. The takeaway for anybody else is that if you can use it, use that over anything else. And that recommendation will probably hold until we get into post-quantum cryptography, which I don't think is going to be mature for the next year or two at minimum.
There's been some talks about adding Libsodium to PHP source.
Yeah, I started RFC for 7.1, but due to other obligations, time constraints, and concerns from members of the PHP internal team like Pierre Joy, they were concerned over which API features in Libsodium to make part of the PHP core. Certain things are redundant, like it has a cache timing safe implementation of bind to hex. PHP has a bind to hex function. It'd make more sense to make the bind to hex PHP uses safe versus adding a whole other function and telling people to use this one instead of that one, because that just might confuse them. So I would definitely love to take all the features that Libsodium provides, look at what PHP already has, see if we can just take the implementations and patch them over what PHP already has for 7.2, and then take all the core functions that we need, like an API like CryptoBox and CryptoSecretBox and CryptoBox Seal. That one is more useful than you'd probably imagine. Take all those and just put them inside of a namespace like sodium underscore CryptoBox, or inside of a namespace function like /sodium/CryptoBox. There's a lot of high-level API architecture details that still need to be hammered out, but that's definitely something that I'd like to see happen to 7.2.
Yeah, so maybe we could set up a like a private chat where you can just sit there and hash out the API, because I definitely would like to get involved on that for sure. I know Elizabeth Smith's been trying to get me to rewrite the ODBC extension in PHP with a new ODBCI extension, kind of like what MySQL got. So I was actually hashing out an API for that, and I was like, man, I really want to get the Libsodium one in there too, because that's going to be, especially now that Encrypt is officially deprecated in 7.1. Although I know we mentioned earlier that Libsodium is not a drop-in replacement for Encrypt, but it does provide, I guess, pretty much all the same features, right? Or at least, like, if you were trying to do something with Encrypt, Libsodium can basically do it too.
Yeah, it solves all the problems that both the OpenSSL and the Encrypt extension tried to solve. It also has its own password hashing features like Argon 2i for password hash and Scrypt. Now that Argon 2i is landing in password hash, I don't think we need that one in particular. That's definitely a decision to talk about when we get into the nitty-gritty. But it's basically a Swiss Army knife of doing things right. Like, if you have to deal with cryptography and you can just offload all the architecture details to, we're going to use Libsodium, this is how we're going to exchange the keys, and we're going to let it take care of all the protocols and all the low-level stuff, do it. Great. You'll probably be better off than trying to write it yourself, unless you happen to be like a cryptographer who's listening on this.
Well, I'm curious if we end up adding Libsodium, if it ends up becoming a requirement for the core, like the standard library, and bin to hex, random bytes, password hashing all point to that flavor in Libsodium. I wonder, like, just go Libsodium crazy, or do you think you get a little bit of pushback for that?
I'd probably get a lot of pushback on that one. There's a lot of stuff we can take from Libsodium. I mean, it's ISC licensed, and if there was any kind of conflict on that, Frank Dennis is a really good guy, and he'd probably be amicable to whatever terms we could, we had to present him with. It's like, well, we need this to be licensed this way. He'd probably be like, yeah, sure, go for it. The main goal for me personally, this is kind of a selfish one, is to make PHP the first programming language to have modern cryptography built in as like a first-class feature. Python doesn't have that. Node.js doesn't have that. Node.js doesn't even have a secure C-spring. They're using OpenSSL's pseudo-random features, which, as we learned from the Ramsey UUID incident, isn't thread safe. So you can, if you have a lot of processes being forked, like in Apache or Fast CGI Process Manager, you can actually get numbers to repeat. So that's a little bit scary. But all these other languages that people say, oh, PHP is trash, use this instead, it's secure. It would be really funny if we turned around and made PHP use the most secure cryptography library that's out there.
That would be awesome.
That would be awesome. It'd be hilarious, and I think it would make a lot of people really jealous.
Toad's jelly. Well, this has been a really good discussion. I mean, I had some more stuff on the show notes, but we are a little bit actually over time here, so we should probably definitely wrap this up. I want to give a shout out to PHP Architect because we did a little sponsor swap. They put a little ad in the mag, and I said, well, I'll give you a shout out on the roundtable. So their official sponsor snippet goes like this: PHP Architect is the monthly journal for PHP programmers. Stay ahead of the curve, discover new tools, and see what's going on in the PHP community. Subscribe today at phparch.com. And for PHP Roundtable people specifically, there's a 25% off coupon deal that you can get for the mag, and it is at phpa.me/PHP Roundtable. It's a great magazine. I have several over my toilet, so that when you're just hanging out, learning some PHP on the toilet, that's where all the best in innovation strikes. Well, it strikes me most there, but the most appropriate places to learn things. I did actually. It's been a little while since we've had a PHP Roundtable because I've had a curse. Because I believe in curses, not really. But the PHP Roundtables had some scheduling conflicts with over the past month and a half. I literally was like, I don't believe in curses, but I think I'm going to start believing in curses pretty soon, because they every time I sent out like invites, either I had the wrong email address for somebody, or like nobody had the same date and time that would work out for them. And sometimes that happens and you have to just send it again. But like every single episode that I was sending them for, like these things were happening. So that's why we kind of I was working fiercely behind the scenes to kind of get one scheduled. But so now we've got a bunch of them scheduled up. Yay! Finally, there's like 3 or 4 that are actually got official dates to them. So that's really exciting. But because of that gap, I haven't told anybody that Pacific Northwest PHP was amazing, because before the last episode was before Pacific Northwest PHP. It was the first conference that I went to that I was actually official speaker at, and it went really well, and met a lot of really cool people there, and it was just like a great little conference. Like it had like a really cool feel to it, just like kind of sort of like when you have like a smaller conference and you just kind of get to know people better and stuff like that. It was like one of those kinds of conferences. And then ZenCon, which just wrapped up last week, and in Las Vegas, was also really awesome. I really I had a great time there. Me and Sarah Goldman, who was going to be on the podcast but didn't make it on today, but we made this video of with our PHP elephant. She has a Hachyderm, which is the HHVM elephant, the only one that exists in all of existence. And we made it was supposed to be a 10-second video, but we made a much longer version with all the elephants just hanging out and playing puppets, and I felt like it's in 3rd grade, but it was a lot of fun. But met lots of really cool people. I gave a talk about contributing to PHP internals and also refactoring legacy apps, and just met some really cool people who got inspired and started contributing, and we had some tests added to the PHP source code and stuff like that. And then I got inspired. I'm like, well, I'm going to finish off this blog that I've been trying to write for like forever about writing tests for PHP. Writing tests for PHP internals, not just for PHP, not PHP unit. So you might be seeing that coming down the pipe here in a second. But also, if you are interested in contributing the show notes to this, to the PHP Roundtable, I have a repo set up on GitHub. It's github.com/PHP Roundtable. And if you go there, you'll see show-notes. That's the repo to contribute show notes. That's all in Markdown. So if you're just listening along and taking notes, I'd love to have your contributions, and the rest of the world can benefit from that. And the last thing before our shameless plugs that I wanted to do is wrap this up with a developer shout out. And this is a segment that recognizes developers for being really awesome in the community. And the way that we recognize those people are by sending them a thank you card and a giant PHP Roundtable sticker, which I've almost gotten rid of all of them yet so far. But we also send a $50 Amazon gift card, and the gift card is sponsored by Laracast.com, which is the de facto way of learning about Laravel, but also about a lot of other really cool things in PHP, like your favorite IDE, or trying to learn Vim or whatever like that. Laracast is like Netflix. You just sit there and watch it, eat popcorn, and then learn about all kinds of really cool things. And Jeffrey Way will teach you the ways of doing PHP in really cool ways. So thank you, Laracast, for the continued sponsorship of the PHP Roundtable developer shoutout. And for this episode, I asked the panel to nominate somebody for the developer shoutout, and they nominated Brian Rederer. I think I'm saying his name right? Rederer? Is that right, Chris? Chris Cornutt, why did you kids nominate Brian?
Well, Brian, he is the PHP developer advocate for Stormpath. They're a kind of a third-party authentication provider. But he's been at a lot of the PHP conferences lately. I think he actually spoke at one, maybe ZenCon, or I forget. I think it was one of them recently, though. But he's a real great guy. I've met him and talked to him a bunch of times, and he's really passionate about helping the PHP community be more secure. Obviously, kind of targeted towards their service, but still just in general. We've had a lot of good discussions about ways that people can improve development practices and all that, and I know he's anxious to share that with others.
Awesome. I think your mic actually has the same problem mine was. It's giving a little crackly sound. Is that happening to everybody, or is it just me? Did everybody hear that?
Yeah, my audio is being a little weird.
Okay. Yeah, I think because if it's the same problem this guy had, the Audio-Technica, man, I got to figure out what's wrong with that because it's such a great mic. But anyway, thanks, Brian, for everything that you're doing for the community. I'll definitely reach out to you and try to get your snail mail address and get this $50 Amazon gift card to you. I've got a couple queued up that I'm going to send out pretty soon. And I guess we can do our shameless plugs. Chris with the crackly mic, would you like to... Chris Crackly mic. Chris Cornutt, would you like to... do you have any shameless plugs that you would like to shamelessly plug? Uh-oh, now I can't hear you. Oh, while you're working on redefining the mic there, how about Chris Riley? You got anything you want to promote?
I've got two things, if that's okay.
Yeah, absolutely.
Yeah, so the first one, probably the bigger one, is conference I'm organising next year in April.
Oh, nice.
It's PHP Yorkshire. It's in York, UK, obviously. And we'll be opening our call for papers early on next month, so keep an eye out on that. The Twitter handle is @PHP Yorkshire. And the second one, another conference, if anybody is in the UK, I'm speaking at PHP Scotland on Saturday. So if anybody wants to go and drop in and say hi, I'm there.
Excellent. What about you, Scott? You have anything you want to promote?
I do, but it's not ready yet. So instead, I've got two things coming down the pipeline we should be making announcements on shortly. So if anybody wants to hear some really cool security stuff, go to paragonie.com, go to contact, and click on our newsletters and sign up for the quarterly newsletter. It's not quite polished enough to be public yet.
Cool. Keeping it suspenseful. What about you, Chris Cornutt? Did you get your audio going? Oh, no. It's probably attack of the crackly mic here. You might. Did you go into settings and switch that in Google Hangouts? I see him pointing.
If he has nothing else to add, I can definitely say if you're not already subscribed to the Security and PHP newsletter or following them on Twitter, that's definitely something that's worth checking out.
Yes, absolutely. And if you want to type anything in the chat too that we can promote for you.
Websec.io.
Yes. Websec.io. Anything else that you'd like to promote? Security tutorials with a PHP target. Awesome. And he's like, that's all I think. Sweet. This is our accessibility episode of the PHP Roundtable, which we already did, which actually was really cool. I definitely think we should do some more accessibility episodes in the future. But this reminded me of that episode. It was like we were typing and like doing. It was like really cool. We had an interpreter and everything. That was a long time ago. But wow, this has been fun. Chris Cornutt, Chris Riley, Scott Arciszewski.
There you go.
Yay! I didn't even look at my pronunciation key for that one. Thank you so much for joining us for this episode, and we'll see you folks in the next one.
Take care.